All right. So we are going to try to do as much of worksheet 5 as we can today. We've already done 1 and 2. If you guys have questions while we're working on these, please unmute yourself and let me know, because I'm watching a screen that's different, different than our Google Meet. I'm going to try to put this up real quick so I can see the chat. Okay, so I'm going to start on problem number 3. And for each of these problems, we were given one data as one representation of motion, and we need to distinguish the other 3. So we're going to start with this one where we're given our position versus time map, and we need to create a velocity versus time graph, a motion map, and a written description. So one of the things that stands out to me about this right away is that we're given a little bit more information than we were before. We have some time information down here. So we can actually divide this up in terms of times. I'm going to just draw a line here for each second. So there's 3, 6, 9, and then there should be 2 divisions within each of these. So that means that I can put little dots across here, and I'll do that in a second. So for our written description, we can go from our position versus time graph to our written description. I know that my object starts motion. It's not at 0, and we don't think it's at 0. I'm going to just at least write not at the origin. Then the object is going to move in the negative direction, so it's moving from a positive position towards a negative position. And it's moving at a constant velocity. Then my object stops. I'm going to also include here that it does this for, I'm going to say from 0 to 3 seconds. That's kind of confusing, isn't it? That's why I set it for first period too. I'm just going to say for 3 seconds. Then in the next 3 seconds, our object stops moving. One, 2, 3. Then lastly, our object moves in a negative direction for 3 seconds. And we can even say, excuse me, we can even include a little more detail and say, object is moving faster than first 3 seconds. You can include that. That's probably more detail than I would require, or I would expect in like a quiz or a test, but we could say that. That's true. So next, to make our velocity versus time graph, what we need to do is take a look at this and think about how that translates to velocity. One thing that we do know is that the slope of a x versus t, a position versus time graph like this, gives us the velocity. So I can take a look at this and say, okay, these horizontal lines, these are the easiest ones. For this, we know that our velocity is 0 meters per second because there's no change in the position. If there's no change in the position, there's no speed and no velocity. Here we've got a constant negative velocity. This one down here is also constant negative. We also know that it's greater than this one, right? So this velocity is greater than the first 3 seconds. So then when I move down to making my graph, first thing I can do is from 3 to 6 seconds, I know that my velocity is 0, so I can just draw a horizontal line right there. I'm going to label that 0. I shouldn't have written that there. Oh well. And then I've got a constant negative velocity. So if it's constant, which means I'm going to draw a horizontal line. It's negative, so it's going to be below 0. Put that down here. And then I've got a more negative velocity here at the end. So it's going to be negative, but it's going to be bigger negative. So I'm going to draw one down here. I'm not sure what those numbers are. I wasn't given any information over here, but I know it's bigger than this. I could have done something like, used a little Post-it note to figure out what this distance was and figure out how many times more this was. But we're just trying to eyeball this. All right. So for our motion map, what we can do is kind of figure out where these dots ought to be. And our motion map, remember, has a dot for each second. So I'm going to figure out where my object was in each second. So I'm going to draw some dots here on my position versus time graph to help me visualize that a little bit. So there we go. And if I kind of translate these over to the side, 1, 2, 3. Am I doing a good job of this? Not really. Sorry about my terrible dot drawing. So there's my first 3 seconds. 0, 1, 2, 3. And then stay still for 1, 2, 3. So I'm going to go 1, 2, 3. And then I'm going to move 3 more seconds downward. But I'm moving faster, so my dots are going to be spread out a little bit more. So this is the shape my motion map should have. They should be close together and it's more spread out, and I'm starting away from 0, moving towards 0. So when I draw my motion map, I'm going to start, I don't know, I kind of want to draw it from 0 instead. So if I start here, put a dot, and I'm just going to make these equally spaced, right? 1, 2, 3, 4 dots. And then I've got 4 dots that are on top of each other. 1, 2, 3, 4. And then starting with that one, 4 dots moving away, but they're close together now. So t equals 0, t equals 2, t equals 3, t equals 4, 5, 6, 7, 1, 2, whoops, I did this wrong. 3, 4, 5, 6, 7, 8, 9. I knew that was wrong because I knew it stopped at 9 seconds. And then lastly, arrows in between all these guys. Does anybody have any questions about number 3? We'll move on to number 4 then. All right, for number 4, we're given our velocity versus time graph, and we need to come up with the other ones. We've also got some extra information here. Our velocity versus time graph has on it actual values for velocity and for the times. So because of that, we can use this graph to figure out displacement, because displacement is equal to our velocity times time. This is the same as when we were looking for the area under the curve. Over here, the displacement is 0. So your displacement is delta x, change in x is 0. Here, we're going from 0 to positive 2, so there's 2, so 1's going to be here. And then 2 to 4 seconds, so here's 0, 1, 2, 3, 4. So this can be divided up into 2. So for each of these, we have 1 second times 1 meter per second. So each of these boxes represents 1 meter of displacement. If each represents 1 meter of displacement, here our change is plus 4 meters. This last one, our object is traveling at minus 1 meter per second for a total of 4 seconds. So if I divide this into 4 pieces, each of these represents 1 meter. So we have 1 meter, 1 meter, 1 meter, 1 meter. But keep in mind that this is negative. So since it's a negative direction, these are going to be minus 1 meter. So in this period of time, the 4 seconds at the end, the displacement is equal to minus 4 meters. So we have 0 plus 4 plus minus 4. So the total displacement here is going to be 0. We're going to end up where we started. Now, I'm going to think about this for a second when I draw it. We're going to end up where I started. So I could start at 0 move 4 meters away, and then come 4 meters back. And I think that that will work. I would be concerned if I was going to travel down into the negative part of my position versus time graph, because it would run into this and it would just kind of look bad. So I don't have a marking here for what 0 is. I'm just going to make one. I'm just going to say I'm starting at 0 meters. We're not told that. It's just something that we're assuming. So I'm going to start with a displacement of 0 for those 2 seconds. So my object is staying in one position. So I'm going to have a horizontal line there. Whenever we have a value or velocity of 0, we're going to have a horizontal line here on position versus time. Then we're going to travel 4 meters. So wherever I decide 4 meters is up here, that's where we're headed. So I'm just going to make it up here. You guys can make it anywhere along there, so and still be correct, and that's fine. So I'm going to draw a dot and then a line all the way up to the dot. Now I know that my object travels 4 meters in the opposite direction after 8 seconds, so I have to figure out where that goes on my graph. I'm going to put it right here, and I'm going to draw a line to it. So there we go. I have an object that was sitting still for 2 seconds, then moved in the positive direction for 2 seconds, and then the negative direction for 4 seconds. And I know the velocities that were happening in each of those, right? We can figure that out. Here, our velocity is going to be our displacement divided by time. So here our velocity is going to be equal to 2 meters per second. It's actually given to us, right? 2 meters per second. Here our velocity is minus 1 meter per second. So we can figure those things out just by looking at these two graphs. For our written description, this is one thing that you can consider if you're not liking this whole list of things up here. You can just describe what happens in each chunk of time. So we aren't told where our object starts moving, but we are told that when time equals 0 to 2 seconds, our object is not moving. So now I'm going to make a list of what my object is doing based on what time it is. That's really terrible, isn't it, guys? I'm sorry about my penmanship there. Then my next piece is from 2 to 4 seconds. So from t equals 2 to 4 seconds. So I don't want to just say 2 to 4 seconds, because if I say 2 to 4 seconds, you might say 3 seconds, 2 seconds. This is a little bit clearer. From 2 to 4 seconds, my object is moving at plus 2 meters per second. So that's a velocity, right? But that also tells us direction because I put a positive sign there. Or you could say object is moving in the positive direction at 2 meters per second. And you could even say for 2 seconds. That's fine too. We need to know how long it's moving for that time, how fast it's moving, and what direction. Those are the 3 important things. The next, from when time is 4 seconds to 8 seconds, object is moving at minus 4 meters per second. So it's telling me that for 4 seconds, my object is moving in the negative direction at 4 meters per second. That's what that statement is saying. And then we can presume that our object stops. We at least know that we don't have any more data after that. Our motion map. So with our motion map, we're going to have a starting position where our object is going to stay still for 2 seconds. So 2 seconds is 3 dots. And then we have another break here, 2, 3, and 4. And then our object is going to come back. So they're going to be at the same point at 3 seconds as they are at 6 seconds. So that's kind of interesting. Then to draw this, I'm going to have 3 dots that stay still down here. And I'm going to move away all the way up to 4 meters. I'm not going to keep him there. I'm going to move him over to the side. And then I know that if I skip one, it should be at the same height there. There we go. So my dots should look something like this. And again, I'm just going to take this shape and translate it down here to my motion map. Oh, I'm so sorry. Let me zoom out a little bit. That will help. All right. So we're going to start at 0 and have 3 dots that are stacked. 1, 2, 3. Then my object is going to start to move in the positive direction, and it's heading towards 4 meters. So if this is 0 meters, 1 meter, 2 meters, 3 meters, 4 meters, my third dot after my second is at 0. My next one at 3 seconds should be at 2. And then I'm going to have that one at 4, but I'm going to zig it down a little bit here because I know that after that point it's going to return. And then I have 1 each meter. So I'm going to go 4, 3, 2, 1, 0. 4, 3, 2, 1, 0. Zero. This one's 2 seconds. 3, 4 seconds. 5, 6, 7, 8 seconds. Does anybody have any questions about number 4? All right, let's try number 5. All right, number 5. Now this time we're given the written description and we're asked to do the other things. And again, we're given 2 times 4 and 6. I'm sorry, 3, 4, 6, and 8 seconds. So this object moves with constant positive velocity for 4 seconds. Then it stops for 2 seconds and returns to the initial position in 2 seconds. So we have it going in the positive direction and then stopping, and then in the negative direction. We're also told it returns to the initial position. So I'm going to start by making my position versus time graph. So it says it moves with constant positive velocity for 4 seconds. So constant positive velocity for 4 seconds. To do that, I just need a straight line that has a positive slope. Then I'm going to stop for 2 seconds, which means for 2 seconds, I'm not going to have any change in position. There we go. Then I'm going to return to the initial position, but in 2 seconds. So it took me 4 seconds here. It's going to take me 2 seconds here. So I'm going to draw a line straight from that position back down. Okay, guys. One thing we aren't told is what this position is. So you could have a tall graph here or a short graph, and that's okay. You can have variation here and still fit the requirements of what the description says. The other thing is it doesn't say that it has to start at the origin here. You can have it starting up here and move upwards and cross and come back down. That's okay too. There's nothing there that says that couldn't be the case. Next, we're going to draw our velocity versus time graph. So I'm just going to take a look at this. It doesn't tell me how fast it's going. All I know is the sign. So I know that up here at the top, my velocity is 0 because I have a horizontal line there for position. So I'm going to draw a line on 0 here for my velocity. And it is important that I note that that's 0. At the beginning, I've got a constant positive velocity. So I'm going to draw a line that's constant positive right here. Then lastly, here I have a constant and negative slope. So that's telling me that I have a slope that's going to be down at the bottom. It's also steeper than this one at the beginning. I know it's covering the same distance as this one, but it's doing it in half the time. So here's something to consider. When you look down here, your velocity versus time graph, the space inside here is the displacement. Right? That's how much distance is covered. We need to make sure that the area down here is similar to this area. In order to do that, I lost my notes, my post-it notes of science. Okay, so what I'm going to do is I'm going to make a little measure here. Since I know it has to be twice as fast because I have half as much time, I'm going to draw a little mark here so that I know how thick that is or how wide that is. Let's see. And I'm going to double it. And that's how tall this should be down here. So, you know, we can estimate this, but I can make it look pretty good, I think. There. So the area here should be about the same as the area here. It's kind of a doodle. Just, just make it close. If you were drawing this and you made it the same height, I would probably give it the side eye and be like, I'm not sure that they thought about this. All right, lastly, our motion map. We're going to start, move away, come back. Now, we know that there's 4 seconds here, so I'm going to make sure that I draw those guys. There we go. All right, so I'm going to move away. I'm just going to assume that these units are the same as my units moving away here, just because it makes my life easier. So I'm going to start, and I'm going to go 1, 2, 3, 4, 5. So I need 5 dots. 1, 2, 3, 4, 5. And this is like fence posts. I have 5 dots, but that represents 4 seconds. And then I have 3 dots across the top up here. Those 3 dots represent 2 seconds. And then my object starts to come back, but it's only going to take 2 dots to get to where it started. So I'm going to make sure that I spread those out so that that works. And draw my arrows. All right, does anybody have any questions about number 5? All right, guys, it's 11:44, which means it's only 1 minute until our class time officially ends, but I'm going to just not start the next one because that would be more complicated.